Okay, hopefully that's recording.
Mm-hmm.
So for this one, we'll probably keep it fairly short. As before, we just do sort of the setup with the OpenAI keys, and a newcom's gonna talk through an example.
All right.
Wait, sorry, maybe I'll just restart. Sorry, I'll just restart this so that we can
Mm-hmm.
go from scratch. Okay, cool. Did you wanna?
Yeah, sure. Um, so so we have seen a bit of like pipelines and RAG before, but so in this one we want to talk about. So given a rack system, we have to we want to do some evaluation to test how good our system is. And of course, like if we have like some point evaluation, then we can see what it lack and then we improve. And that improvement we can report to make a paper. I mean, that's where like RAG's papers are really coming out like this. So so to achieve that goal, for us. So I started with the example. So what I did here is, so I took this article from New York Post about Perelman and Yao controversy. And so what I did is like I took the data and write it in the file document.txt. And I saved it here and yep, so that is the file. So yes, and after I take the file, then like I just use again the document loader from LangChain to load the document in our Jupyter environment. Now, yeah, so now we have the document loaded. So this part of the code right now. So what I want to introduce the thing called chunking. So what is chunking essentially is like you, for example, you have a text like this. This is a long text that we want to split into smaller chunks for processing. Each chunk will have a maximum number of characters. So we want to take this whole kind of text and make it in small bits so that it will be easier for a large language model to process. Yeah. So this splitter um, class, if we give the parameter of the size of the sentence you want to split, like with 50 characters, and the overlap is 10 character. And if I pass that, and so that look, the sentence is being splitted in like this bit like 1, 2, 3, 4. This is like a long text that we want to split into. Then split into is the intersection, that is the 10 character that we said. And you have this. So these are called chunks. Yeah. So now we do the chunking for the document we extracted from the website. And we set up the chunk size to be 500 and the overlap to be 50. And we have to also tell us what are we separating on. We are separating on the space that is given by /n. And you can see in the red bit, the created a chunk of size 525. So yeah, these chunks are created. Now,
And
as the chunks
I
are
think this is.
created, so you can see one example of a chunk. So it is kind of like some passage.
Yeah, and I think we split on new lines, so we'll
Right.
probably see a little bit of repetition between
Yeah. By the
the
way,
different
both of we and me
sections.
is kind of a math background. So
Oh,
sorry,
okay,
if
sorry.
I'm that is Min, right? Min, you know who is Perelman and Yao?
Huh?
You know Perelman and Yao. Sorry, that can I don't know how to pronounce your name. That is Hugh.
Oh,
I,
yes, you're good.
Ah,
Just call me Min.
Carmen.
Yeah.
Yeah, I know
just
this
call you what?
guy.
Sorry.
Ming.
Yeah, it's a
Min,
Russian
okay.
guy, right?
Yes.
Right. Min, you know who is Perelman and Yao?
Yeah.
Yeah, you
And
know, you
I
know.
don't know
Yeah,
him.
it's a Russian guy who turns down
Right,
film's
right.
medal,
So
right?
he's a famous Russian guy, and that's like the article is very interesting. Yep. So yeah, right. Like, let's come to the talk back. Yeah. So you see, like it is kind of the chunk like this, and then like now actually, so right now, what we have processed the chunk. Now we want to do the vector embedding for each of this chunk. So what we do is like we kind of call the ChromaDB vector embedding from LangChain, and we use the OpenAI embedding. So that is kind of this line of code is doing. So we want to embed, we say the vector store. We documents is the chunks that we created. And yeah, so we embed those chunk as a vector right now. So each chunk would be a vector of size, say 1532 dimension. And then we also use the class of retriever function to, so if you remember from last bit, what is a retriever? That is kind of a function that, or a class that would, given a question, it will retrieve the best chunk relevant to the question. And then that would create the context. And so with that bit, we would then we will start creating the RAG chain pipeline. Now for that, we need to define a template to tell the large language model what is the task for the language model. So here I said that you are an assistant for question answering tasks. Use the following piece of retrieve context to answer the question. If you don't know the answer, just say that you don't know. Use 3 sentence maximum and keep the answer concise. So you see that the question and the context are in the quotation. That means they are treated as a variable. So we could put the question, and also we retrieve the context. And based on that question and the context that is on the document, the answer would be given, right? Yeah. So if we run this, you see that, oh,
You forgot to run the buff code.
yeah,
Yes.
right.
Thank you.
Oh, yeah, thanks, man. Yeah, you see like the input variable that is context and question and the template and this. Okay. Now like here is the bit that we are creating the very basic rack chain pipeline where we are giving the context that would be given by the retriever based on the question, and runnable pass-through means we are not doing anything to the question, like that last time we were discussing what is runnable pass-through, runnable parallel. Now, yeah, so that is kind of the rag chain. So yep, after this, we can use the rag chain to ask any question from the document that we extracted. Yeah. Now, okay, so yep. So yeah, so now we have created a kind of a yeah, like a rack system that can question answer based on the document. Now we want to evaluate our system, how good it is doing. So for that bit, we have to make something. So we want to test. So I created this by hand. Like I asked, like, okay, who is Yao? Who is Perelman? What is Poincare conjecture? And then I put some ground truth. So I said, okay, Yao is a professor of mathematics at Harvard. Perelman is a mathematician. And Poincare conjecture is century-old conundrum, etc., etc. Um, so now we want to test how our rack system is doing to answer this question, if they are kind of extracting the relevant chunk and kind of giving the right answer. So to do that, we Yeah, so then we created a dictionary like this and run our rack system on that, like, and it kind of fill those things up. Like, yep. So this answer and the context are kind of derived from our rack system, right? Like we give the question and it gives us the, and yeah. Uh, so we want to test if like doing at all any good. So for that, we have to convert it to a format called dataset because of the library we're going to use that's required this. So to test a rack system, there is a library called Ragas. So it has like 4 kind of score, that is like faithfulness, answer relevancy, context recall, context precision. Oh, sorry. It has not those things. Context precision, context recall, faithfulness, answer relevancy. So your system would be tested on the scores given by all these 4. And yeah, if we run, then it will do the evaluation, and later we can explain at least one of the metric, and you can then later find out the other metrics. So yep, so you see like oh, it got 1 right now. Okay, because we changed to Perl. Okay, so for example, if we see row 2, who is Perlman? So Perlman is a mathematician known for his by the, so this is the answer it gave, and the context is like context means the document, it, like, remember the chunk, so it also tells how it formed the answer by taking information from that chunk. Yep. So yeah, right, so it retrieved the chunk by the retriever class.
Yeah, so for who is Perelman, this is the first one, would be
So
these were
basically,
the two
the
chunks that
context
came
is where they retrieve the information from, right?
Correct. Yep.
Yeah.
Chunk.
So
Yeah, which
I have
chunk?
one more
Yes.
question. Like, why do
Yes.
we need the overlap things when we chunk the document?
One thing I feel is like just to have a contextual or semantic flow to, but yeah, why we need a overlap? Um, yeah, like yeah, I don't know, like if I yeah, and any answer to this?
Yeah, I'm not sure if it's strictly necessary or not, but like, firstly, we probably don't want to split at just sort of the word level. You could end up with sort of half-finished sentences. And also, there's no guarantee that the chunks you get retrieved back are going to be one after another, because the chunks are just sections of the document that are the closest. So like you can't rely on having, like if there's 2 sentences where one's sort of dependent on the previous one,
Yeah.
you kind of want everything that's kind of relevant in that chunk, because there's no guarantee we'll see anything else from these chunks. So in this case, we were just returning the 2 most relevant chunks for demonstration purposes. In practice, you might want more than just the 2 most relevant. But like these don't necessarily follow each other in the document at all. They're just 2 arbitrary parts of chunks taken from somewhere in the document that seem to be closest to the question. So I think that might be why it's okay to have a little bit of overlap, but whether it's strictly necessary or not, I'm not quite sure.
Right.
So
Correct.
can I see the matrix when you test the model? I want to see the first answer. who is Zhao? Okay, so
Mm.
answer relevance is I can see that the answer for the first question is not what we expect it should be, because in the ground truth it say that Zhao is mathematics at Harvard, but in the answer I just read it before. There's
Yeah,
not
and you can see that we got 0 context recall and precision there. So let's see what went wrong with that first one. So question was, who was Yao? And you can see for the context we got back for the first one. We got back some context about Yao, but it was all about kind of his early upbringing, about like his father died of kidney cancer and how about he moved to Hong Kong. And so, unsurprisingly, the answer we got back is also just sort of based on the context we got, but not really anything about the ground truth. So I think that's why we were seeing, like when we scored it, we also saw 0 precision and recall, context, precision and recall, which just basically means that none of the ground truth that we wanted. So the fact that he was a professor of mathematics at Harvard, none of that appeared in the
I can't see
context.
Harvard.
So I think that's, yeah, I think the scoring's telling us what you sort of picked up intuitively, which is that, yeah, the ground truth answer didn't appear in any of the context and therefore also didn't appear really in the answer.
So, but is that because we do not provide enough context in the document, or because the LLM cannot find the best one related to the
Yeah, I'm not sure if it's that it just wasn't mentioned in the document, or maybe it's mentioned in the document, but the 2 most relevant chunks that we got back might not have contained the answers. So, like, something to try is, like, if we were to increase the
Number of
number of chunks that we retrieve back, like we could increase it to 5 or 100, but you probably don't want to go too big because then you end up with a larger context window.
Yeah. But can you double check is there any word like Harvard in the document, in the above document that you provide for the LLM?
Correct. Yep, let's see. Actually, I created just by myself because I know it, but you're right. Yeah. Can we see if there is Harvard there?
Oh yeah, I can see Harvard.
You can see Harvard. Wow. Yeah. Oh, here. According to the Chinese, find it. Yeah. You definitely he agreed to.
Oh yeah, he agreed to go Harvard.
Yeah, so I think the answer in this case is here in the document. But because the question was just who is Yao, when we tried to retrieve the relevant chunks, it would have just retrieved 2 chunks that were about Yao, but not necessarily about where he worked. So I think that's what went wrong in this case.
Yeah, like if we are doing it more professionally, maybe we could use like I think Jeskin or certain things to make up the questions automatically in the ground truth. But this one I hand coded, but also it is interesting, right? Like I don't know if a person is reading the text and I don't know if I read the text, if I know that it would imply that I know Yao is a professor in math, but like at Harvard, but yeah, I don't know if
I was thinking let's maybe try and reword the question, and then maybe based on the fact that I've now got university in the question, hopefully it'll bring back a chunk that's talking about a university. And the other thing we could try is like increasing the number of chunks we get back. I have no idea if this will work, but let's try it.
Yeah, now we increase the K to 5, like it will retrieve 5 chunks.
Yeah, so retrieving more chunks, and also I think including that keyword university will probably make it more likely that a chunk that mentions a university like Harvard will come back, hopefully. So yeah, this I think is the advantage though of now having metrics is that we can start playing around with things and know if we're improving on that.
Correct.
So you just increase the number of K, right? You
Correct.
assign K equal to 5, so that means you retrieve 5 different chunks. Is that true?
Correct.
Yeah.
Yeah.
Yeah, so I can see now the context recall's gone up to 1, which I think means we
Yeah,
can
it can
check.
answer.
Oh yeah, cool.
You work at
Yeah, I
Harvard.
worked as a Harvard University.
Cool.
So I think
So
that
how do
means
you
that the
how do
answer
you
was there.
calculate this context precision?
Yeah, you can see that the recall went up, but the precision's only 0.2. So I think the precision is low because we've now retrieved more chunks, and some of those chunks will be irrelevant.
Right.
Okay.
Okay.
But how do you compute?
Yeah,
How do
right.
you,
Okay, how we calculate it, right? Okay, so I think let's look at the documentation by yep. Let's see. We were looking at the things, and yeah, we should know this definitely,
I'll
right?
start with recall because that one's the easiest to define. It's probably easier to just look at the example. So recall on the denominator there, it's just the number of claims. So in this case, that he was a professor at Harvard, which I'm not sure in this case if that counts as 1 or 2, that he was both a professor and a professor at Harvard. And then on the top, we've got how many of those claims appear somewhere
Can
in
you
the
make it a bit
context.
down, like it is like getting blocked by the meeting, something, or everyone can
It's
saw the formula? Everyone can see the formula? Okay.
well, actually, how do you tell if one claim is equivalent to another one? Is that a feature of a large language model as well? Because if you have two sentences and they phrase a little bit differently, but they say the same thing, it can tell that it claimed the same thing and count as equal.
Yeah, exactly. So I think Ragus itself is using a large language model underneath to do the evaluation.
Yes.
Okay, and we can trust that that thing is like accurate.
No, not necessarily.
Not necessarily,
Good
So,
question,
exactly.
so
but
the
I
error
think it's the
can
best we can
actually
do.
propagate, right? There's a propagation of error.
Yes. Yes. So yeah, like the context recall, you see, like for example, here, like we make the claim, like the ground truth for our case has how many claims? Okay, we can just go for this example. Like, you understand this example though? Like how they're
Okay.
calculated.
So, like the answer is first Super Bowl was held. Okay, so it answer like several things, and then you just count how many of that is correct.
Yeah, so maybe let's
Okay.
do their example.
Yeah.
Where's France in its
Oh,
title?
okay, that's easier to read.
So in this case, even though it's a single sentence, so this is why I was saying, like, for Yao, I'm not sure if a professor at Harvard counts as one thing or two. So in this case, one of the claims would be France is in Western Europe, and the second claim is that the capital of France is Paris. So this is really sort of two claims. And then we check how many of those claims appear in the context. So like for this low context one, we've got the claim that France is in Western Europe, but nowhere in this example does it mention anything about Paris. So in this one, we'd say we've got one out of the two claims, and so it's only 50% recall. And so there can still be a whole lot of extra irrelevant stuff in the context, and that doesn't really affect it. But for recall, we're just checking, does everything in our ground truth appear somewhere within that context? So like in this case, we were getting a recall of one, which means we could have still had a whole lot of irrelevant contexts, but at least the fact that he was a Harvard University professor appeared somewhere in the context that we were getting back. Precision, though, is a little bit more interesting. So like for this one, even though we got high recall, we were getting low precision. So let's just check the definition of that. Again, I think the examples actually help more than the formula here. Okay, so for this low precision example, you can see they've got France is in Western Europe and Paris is its capital. So all the facts are there, but I think this one is probably low precision because we also got a whole lot of irrelevant information back. Okay, cool. So I think this is saying, okay, I'm about to get kicked out of the library. So for the most relevant context that we got back, like the first one, I think it's saying the answer didn't occur at all. And then when we consider the two most relevant parts of the context, it appeared in the true positives, false positives. Okay, so I think maybe it's saying when we consider the two most relevant, we've got one true positive and maybe this first one's still a false positive. I'd have to check that. Yeah, ideally the relevant chunks must appear at top ranks. So yeah, I think this one is being penalized because it's only the second context that was really relevant. And so ideally that should have been the first thing we got back rather than the second ranked one. So if we look at ours, there's Perelman. Yeah, I think it's because even though we do have the answer in one of the contexts. It's not really, it doesn't actually appear in the top ranked chunk that we got back, which might be why we got a low precision.
Or maybe like the denominator will be 5, but the chunk that was relevant is only 1. Like total number of relevant item in the top K result, so that is 5. But only one chunk have the answer, so maybe 1 by 5 is 0.2.
Yeah, possibly. I think, yeah, the formula is a little bit more complex in that I think they sort of consider just the first one, and then the top 2, then the top 3, then the top 4, and then sort of take an average of them all. But
Right.
like by the time we get to 5, yeah, there's probably something that was relevant in that 5, but probably not a lot in the top relevant chunks. So yeah, I'd have to look into more exactly how they calculate the formula, but hopefully intuitively you sort of get a feel for it.
Yeah. Maybe yeah, we can go back.
We might have to end there because I'm gonna get kicked out of the library in 5 minutes.
Yeah, right. Like, yeah, we can stop the recording anyway right now. I think, yep.
Yeah, it's great.
Yeah, thanks everyone. I'll stop the recording there.